Good morning, class 10th. Yesterday we did one theorem in circles, and the theorem was the angle which an arc of a circle subtends at the center is double that which it subtends at any point on the remaining part of the circumference. APB was an arc which subtended an angle AOB at the center, and remaining part of the circumference, leave this part APB and pick up C on anywhere on the remaining part of the circumference. So we picked up C and joined C to A and C to B. Then this arc APB subtends angle AOB at the center and ACB at any point on the remaining part of the circumference. Then according to this theorem, the angle at the center is double the angle at the circumference, subtended by the same arc. Subtended by the same arc. So we proved it yesterday by showing you. Now I am going to start some basic problems or practical problems on this, because proof is not that important as the application of the theorem is important. Now I have drawn four figures, 1, 2, 3, 4 on the right side of the board, and let's pick up question number 1 for example. In question number 1, O is the center of the circle. The arc AB, that is, arc AB is a minor arc. We explained you that this is the minor arc. The arc AB subtends angle AOB at the center, which is 60 degree, and we have to calculate any point is on the remaining part of the circumference, and A is joined to C and B is joined to C. So we have to calculate what is the value of ACB or X. We know, number 1, X will be 1 by 2 of half of the angle at the center. Because we are saying angle subtended by an arc at the center. Suppose I give it a name P. The arc APB subtends an angle AOB at the center. So, and the same arc subtends an angle ACB at the remaining part of the circumference. Then the relation is that angle at the center is double the angle at the circumference. Angle at the center is double the angle at the circumference. The relation is, I will write it like this, that angle AOB is double the angle at remaining part of the circumference. This is what we had proved yesterday. I have left the figure here for your understanding. This angle was x plus y, so this came out to be 2x plus 2y. 2x plus 2y means 2 you took out common, x plus y was remaining inside. So AOB is double of ACB. So AOB is double of ACB. And AOB is how much? 60 degree. AOB is 60 degree, and ACB we have to calculate, which is x, or 2x is equal to 60 degree, x will be 30 degree. X will be 30 degree. The reason is angle at center is double the angle at circumference subtended by the same arc. Subtended by the same arc. Subtended by the same arc. Arc has to be same. Arc has to be same. This angle AOB and ACB, you have to see the base has to be same. AB is the same. If I join this to this, A to B, the chord AB, you would realize that in the triangle AOB and then the triangle ACB, the base is AB. So the relation is only when the base is same. If the base is not same, then this relation cannot hold good. This relation holds good only when the base is the same, AB. When I am saying AB chord is same, that means arc ABB is subtending an angle at the center, and the arc APB is subtending an angle at the remaining part of the circumference. And the relation I have told you is AOB is double of ACB. So AOB was given in your picture 60 degree, and ACB was given as x, so 2 into x. 2x is equal to 60, so x will be 30 degree. Now let us see question number 2. In question number 2, he has given you again AOB and ACB, but he has reversed the process. Instead of giving the angle at the center, he wants you to calculate angle at the center, and angle at the circumference is given. Again, please, I am insisting this point that the base is the same, the base AB is same, then only AOB will be double of ACB. If the base is not same, this relation will not hold good. Now again in the second question, second figure, I would say angle AOB is double of angle ACB. So AOB is y, and this is 2, and ACB is 40, so it will be 80 degree. The reason is the same. Angle at center, I'm not going to write it again, it's already written on top. Angle at center is double the angle at circumference subtended by the same arc. It is important to write, it is important to understand same arc. Arc is same. Arc cannot change. By the same arc, it has to be the same arc. It is written here also. And please understand the relation hold good. If this arc is used like here, minor arc we are using, then the point C will be on the remaining part of the circumference, which will be the major arc, which will be the major arc. Now let us see question number 3. I'm just going to wipe it off from the board, 1 and 2, and I will wipe these off also. We'll pick up the third question now. In the third figure, notice that he has given you a diameter actually. Any chord, biggest chord of the circle is diameter. This BOC is passing through the center. O is always representing the center of the circle. BOC is diameter. Any chord which passes through the center is called diameter. It is called the biggest chord of the circle. And the arc, again arc, suppose AKC. This is a minor arc again. This is a minor arc. The angle here is, you can see it is an acute angle, it is a minor arc. And the remaining is reflex angle, so the remaining arc is major arc. The arc AKC subtends angle AOB at the center, and this angle BAO is 30 degree. We have to find the value of x. We have to find the value of x. So what are we going to do? Let us look. Let us see in triangle OAB. I will say in triangle OAB. In triangle OAB, I'll have angle OAB equal to angle OBA will be equal to 30 degree. OA is equal to OB radii. Because OA and OB are equal, we told you that radius, the distance between a moving point, these all B, A, C are moving on the circumference of the circle. O is center, which is a fixed point. The distance between the fixed point and a point which is moving on the circumference of the circle and getting us the locus, which is called circle, then this OB, OA, OC all will be of the same length, because radius does not change for one particular, for a unique circle. For a unique circle, unique radius is there. So OA is equal to OB, because radii of a circle is same, we are using the same circle. And if two sides of a triangle are equal, then the angles opposite to them are equal. Now in this triangle OBA, I have OA is equal to OB. So angle OAB will be equal to angle OBA. This will be 30 degree. This will be 30 degree. Because if two sides of a triangle are equal, then the angles opposite to them are equal. Now I have got this angle as 30. Now this arc AKC subtends an angle AOB at the AOC at the center, and AKC subtends angle ABC at the circumference. So again we will have relation that OAC or AOC, the angle at the center subtended by the arc AKC, will be double the angle which it subtends at the remaining part of the circumference, that is ABC. So AOC will be double of ABC, and AOC is X and ABC is 30, so it will be 60 degree. We have got the value of X as 60 degree. Another way of understanding is this, that exterior angle of a triangle is equal to the sum of the interior opposite angles. We had used this property while proving the theorem, if you remember. This AOC is the exterior angle of the triangle AOB. Exterior angle of the triangle is equal to the sum of the interior opposite angle. So X will be equal to 30 plus 30. I can use that property as well. Now let us see the fourth question. This is the fourth figure. Let us see the fourth question. In the fourth question it is given that again this arc, suppose I say arc ALB, it is a minor arc again. When this angle seems to be less than 180 degree, the arc is minor arc. It is less than 180 degrees, so it will be minor arc, and the remaining arc will be major arc. ALB is minor arc and ACB is major arc. Now he has given you O is the center. Wherever O is there in the diagrams of circle, we consider it always as a center. He has given you that angle AOC is like this, angle ACB is like this, C is joined to O and produced further, suppose let me name it D. COD is a straight line. What he has given you, he has given you AOD as 30, he has given you DOB as Y, he has given you angle ACO as X, and he has given you angle OCB as 40. He wants to calculate the value of angle X and Y. He wants you to calculate the value of angle X and Y. Please understand that OA in triangle OAC, in triangle OAC, in triangle OAC, I would say angle OAC is equal to angle OCA is equal to X. It is equal to X. Why? Again, OA is equal to OC radii. They are the radii of the same circle. And if two sides of a triangle are equal, if two sides of a triangle are equal, then the angles opposite to them are equal. Sides are equal, angles opposite to them are equal. We know the property that the exterior angle of the triangle AOD is the exterior angle. So AOD will be equal to the sum of the interior opposite angle. So X plus X will be equal to 30 degree. Exterior angle of a triangle. When I write exterior angle of a triangle, you need to write the complete property that exterior angle of a triangle is equal to the sum of the interior opposite angles. I am not writing complete thing, but you must understand what I am trying to say to you. So X plus X is 30, 2X is 30, so that will imply X is equal to 15. X is equal to 15. You've got the value of X as 15. You've got the value of X as 15. Now I have this angle Y. I will do the same thing to triangle OCB. In triangle OCB, I'll say angle OBC will be equal to angle OCB will be equal to 40 degree. Because this was given 40 degree, so this will be 40 degree. This will be also 40 degree. This will be also 40 degree. Now again the exterior angle of the triangle Y will be 40 plus 40. So Y will be 40 plus 40, that is 80. Exterior angle of a triangle. Exterior angle of a triangle is equal to the sum of the interior opposite angle. So I have got both the values x as well as y. I got the value of x as 15 and I have got the value of y as 80. Let us see. X plus 40 is how much? Your angle ACB. Your angle ACB is x plus 40, that is 15 plus 40, that will be 55. This is 55 degree. This is 55 degree. And let us calculate what is angle AOB. It is given 30, that is y plus 30 or 30 plus y. 30 plus y, and I have calculated y to be 80. So 30 plus 80 will be 110. Now you can see what is the relationship between angle AOB and ACB. ACB is 55 and double of 55 is AOB, which is 110. Double, if you multiply 55 by 2, you will get 110. So angle at the center is double the angle at the circumference subtended by the same arc. Let's look into question number 5 now. Continuing with the same proposition that the angle which an arc of a circle subtends at the center is double that which it subtends at any point on the remaining part of the circumference. Here again the figure, just look at the figure here. The arc APB is making an angle AOB at the center. A is joined to C and B is joined to C. C is any point on the remaining part of the circumference. So APB is minor arc, ACB is major arc. He has joined C to O and extended it to D. This angle OAC is given as 25 degree. Angle OBC is given as 20 degree in the figure. He wants you to calculate angle ACB as well as angle AOB. So what are we going to do? We are going to pick up the triangle OAC. In triangle OAC, I would say that angle OAC is equal to angle OCA is equal to 25 degree because OA is equal to OC radii. This is 25. This is 25 radii of the same circle, so the two angles will be equal. The another is angle property is that the exterior angle of a triangle, OAC is a triangle. I have extended side CO to point D. Then this angle AOD will be equal to 25 plus 25, that is 50 degree. Be 50 degree. The property is exterior angle of a triangle. Exterior angle of a triangle is equal to the sum of the interior opposite angles. Similarly, let us pick up the triangle. This has come out to be 50. Now let us pick up the triangle OBC. In triangle OBC, I would say that angle OBC is equal to angle OCB will be equal to 20 degree as OB is equal to OC. OB is equal to OC, radii of the same circle. Radii of the same circle. So these, at this angle will be 20. So angle BOD will be 20 plus 20, that is 40 degree. Exterior angle of a triangle. Exterior angle of a triangle. Now you have got all the angles. This has come out to be 50. Actually it is funny, looking to be 50 plus 40 is 90. It is looking to be 90, but it doesn't appear in the figure to be 90. And that angle is how much? 25 plus 20. 25 plus 20 is 45. 25 plus 20 is 45. Angle at the center is 90. Okay. So the angle AOB is equal to 50 plus 40 equal to 90 degree, and angle ACB is equal to 25 plus 20, that is 45. It is perfectly alright. The angle at the center is double the angle at the circumference subtended by the same arc. The arc APB subtends angle AOB at the center, and the arc APB subtends angle ACB at the circumference. Then the relation between the two angles is angle at the center is double the angle at the circumference. Okay, let's look into the sixth question. Look at the figure on the side. O is the center of the circle. Now here a little difference is there. The point B is taken on the minor arc. So if point B is taken on the minor arc, that means the major arc is subtending that angle. That means major arc, suppose I name it Q, then major arc AQC is subtending an angle ABC at the circumference, and it is subtending angle, reflex angle AOC. This is reflex angle. Any angle which is greater than 180 degrees is called reflex angle. This is reflex angle AOC, and this 112 is reflex, it is angle AOC. Angle AOC, and this is reflex angle AOC. Any angle which is less than 180 is simply you can refer as AOC like here, and beyond that, the opposite side I am referring as reflex angle. We have to find the relationship between x, we have to find x, and it is given as 112. So what I will do is I will calculate first of all reflex angle. Reflex angle AOC. That will be 360 minus 112. Because angle at the center or angle at a point, the sum of angles around a point, for example, this is a point and many lines are there. So the sum of all these angles A, B, C, D, E, the sum of angles around a point will be 360 degree. Here only two angles are there around this point O. So angle AOC plus reflex angle AOC will be equal to 360. So if I have to calculate the reflex angle AOC, it will be 360 minus 112, that will be 8, and 248. 248. 48 plus 12 is 60 and 100. Okay. 10 minus 2 is 8, 5 minus 1 is 4, 3 minus 1 is 2. Okay, it is 248. It has to be greater than 180 degree. Reflex angle has to be greater than 180 degree. So angle ABC will be or reflex angle AOC. Let us write reflex angle AOC will be double of angle ABC, that is double of angle X. So 248 is double of X. So X will come out to be 248 upon 2, that is 124. So angle subtended at the center is double the angle which it subtends at the remaining part of the circumference. Here this reflex angle is coming out to be 248. Please understand, it is just the reverse case of this. Here the major arc AQC is subtending angle, reflex angle AOC at the center, and the same arc, major arc ABC, is subtending the angle ABC at the remaining part of the circumference. So you will have to look that where is the angle this point C is lying, or this point B is lying. B is lying on the minor sector. So that means the major sector is major arc is subtending the angle here. Here the C is lying on the major arc. So the minor arc is subtending the angle. That's what you have to differentiate. 360 minus 112, 248, and half of 248 will be 124. That is the angle X. Now let us see question number 7. In question number 7, we have O is the center of the circle, A is joined to B, ACB is given as 50 degree. We have to find the value of X. We know that angle AOC, that is angle at the center, will be double the angle at the circumference, ACB, subtended by the same arc. Which is the arc? Let me take a point P. APB, it is a minor arc. It is a minor arc. C is on the major arc. So APB is minor arc. Minor arc is subtending angle AOB at the center, and the same arc APB is subtending angle ACB at the circumference. So what is the relation? Angle at the center is double the angle at the circumference. So it is 2 into 50, that will come out to be 100. Reason is angle at center double the angle at circumference, double the angle at circumference, subtended by the same arc, subtended by the same arc. So this angle comes out to be 100 degree. This angle comes out to be 100 degree. Now in triangle OAB, angle OAB will be equal to angle OBA will be equal to 180 minus 100 and divided by 2. Why are they equal? Because OA is equal to OB, radii of the same circle. OA is equal to OB, radii of the same circle. They are radius of the same circle or radii of the same circle. So 180 minus 100 is 80, 80 upon 2, that will be equal to 40 degree. This angle X will be equal to 40 degree. This angle X will be equal to 40 degree. Okay. The angle which an arc of a circle subtends at the center is double that which it subtends at any point on the remaining part of the circumference. Based on this theorem, we are doing problem. Now I am on problem number 8, in which it is given that AOB is diameter. Diameter is the biggest chord, a chord which passes through the center. CD is another line. CD is another line which is cutting this AB. And D is joined to point B. Angle AOB is 110 degree, it is given. Angle CDB is marked as X. I have to find the value of X. Now let us see how do we do that. This is 110. This angle is 110. I can calculate this angle. What will be this angle? This is angle COB. Angle COB will be 180 minus 110, 70 degree. Why is it so? Because AOB is a straight line and the adjacent angles formed on a straight line are supplementary. So AOB is a straight line. That is what the reason is. A straight line is of 180 degree. One of the angles on one side is given 110. So the adjacent angle COB will be 180 minus 110. That will be 70 degree. This angle is 70 degree. Let me name this CPB. Now the arc CPB, the arc, this arc CPB, you can see it. The arc CPB subtends angle COB at the center, and arc CPB subtends this another angle at the circumference of the circle. This point D is on the other part of the circumference, remaining part of the circumference. It is not on the CPB. The point D is on the remaining part of the circumference. Please go through this statement. The angle subtended by an arc at the center of a subtends at the center of circle is double that which it subtends at any point on the remaining part of the circumference. So this arc CPB is subtending angle COB at the center, and the same arc is subtending angle CDB, whereas D is on the remaining part of the circumference. When I say remaining part, means you leave CPB and pick up D anywhere on this, on the remaining part of the circumference. Then the relation is that the angle at the center is double the angle at the circumference. So I would say angle COB is double the angle CDB. Angle at center is double, or we should write simply double angle property. Instead of this, write double angle property. Double angle property. What is the double angle property? This is the double angle property which is written on top, that angle subtended by an arc at center is double the angle which it subtends on any point in the remaining part of the circumference. So COB is double of CDB. Let us see what is COB. COB is 70 and it is 2 into x, or 2x is equal to 70. So x will be 35 degree. The value of x you have to calculate. We are using time and again. This is the 8th problem which I am doing on this particular theorem. There are many questions which you can do, and if you have problem you can get back to us. I will be doing the last problem on this now, question number 9 on the same exercise, on the same theorem. Let's see question number 9. In question number 9 we have B, C, A are the points on the circumference, and all these points seems to be on the minor arc. O is the center. O is the center. This, if I name it as P, then BPA is the major arc. BPA is the major arc. BPA is the major arc. O is joined to B, B is joined to C, C is joined to A is joined to O. The angle, this angle BOA is given as 140 degree. Angle B is Y, angle A is 50, and angle C is X. We have to find the value of X and Y. First of all, let us calculate reflex angle BOA. Reflex angle BOA, which will be 360 minus 140. It will be 220 degree. Because sum of angles around a point is 360 degree. This total is 360 degree. Out of that, how much is gone? 140 is gone. So the remaining is reflex angle. For that reflex angle, what I've done, I've subtracted 140 out of 360. I got 220. So this is reflex angle BOA. Now the relation is the angle at the center, reflex angle BOA is double angle BCA. Double of angle BCA. This is 220. It is double of x, or x will be 220 upon 2. That will be 110. So I've got the value of x. I've got the value of x as 110. Half of 220. Half of 220. Now this is a quadrilateral. OACB is a quadrilateral. Any plane figure, any plane closed figure bounded by 4 straight lines is a quadrilateral. And sum of the interior angle of a quadrilateral is always equal to 4 right angles. It is always equal to 4 right angles. That means sum of all these angles will be 360 degrees. So in quadrilateral OACB, x plus y plus 50 plus 140 should be equal to 360. Sum of angles, sum of interior angles of a quadrilateral is 4 right angles. 4 right angles. So this is 360 degree. I've already calculated the value of x. What is the value of x? 110 plus y plus 50 plus 140 is equal to 360 degree. 140 plus 50 is 190. 190 plus 110 will be 200. Will it be 200? No. 150 plus 50 is 140 plus 50 is 190. It will be 300. So y will be equal to 360 minus 300, and that will be 60 degree. So the value of x we have calculated as 110, and the value of y we have calculated as 60 degree.